Most LLM products still behave like they know more than they do. That is the real reason this implementation matters. It is not just another prompt stack. The tutorial builds a system that asks the model for an answer, a confidence score, and a reason for that score. Then it adds a second pass where the model critiques its own output. If confidence stays low, it triggers web research and synthesizes a better answer from live sources. For product teams, that is a practical shift. You are not only generating text, you are deciding when the system should trust itself and when it should slow down and look outside. That can improve transparency and make failures easier to inspect. But it also raises the key engine in the title: is this a real guardrail? Or just more model-generated ceremony around the same uncertainty problem? The source is very explicit about the mechanics. It sets up a Python pipeline around the OpenAI API and a structured response object that stores the question, answer, confidence, reasoning, and research metadata. The first function asks the model to return strict JSON with an answer, a confidence score, and an explanation. That matters because it turns a vague chat response into something a program can root and inspect. The next step is self-evaluation. The model reviews its first answer and can revise both the content and the confidence. After that, the system can call DuckDuckGo search when the confidence threshold says the answer is weak. Then it synthesizes search results with the draft answer into a final response. There are also helper functions for confidence labels, console formatting, batch evaluation, summary tables, and an interactive mode for repeated questions. The biggest change is not the search step. It is the routing logic around uncertainty. A normal LLM app often gives one answer and stops there. This implementation turns uncertainty into an explicit control signal. If the confidence is high enough, the system can respond directly. If not, it takes a more expensive path and does research. That gives developers an op they can tune for latency, cost, and evidence quality. The second meaningful change is observability, because the pipeline records confidence, reasoning, and whether research was triggered. You can inspect system behavior across many queries instead of guessing why a response felt weak. The article also shows batch runs in the summary table, which is useful for evaluation. The limit is that the confidence score still starts as self-report, so the architecture is more disciplined than standard chat, but it is not the same as externally validated calibration. There are real gains here, but they are specific. This design is useful when the cost of being confidently wrong is higher than the cost of a slower answer. Decision support, internal knowledge tools, and research assistance fit that pattern. The model can admit uncertainty, run a second check, and pull in external information when needed. That is better than forcing every answer to sound final. The clean console display and source tracking also help users see why the system answered the way it did. But the strongest claims should stay in arrow. Self-evaluation can catch obvious issues. Yet models often agree with themselves too easily. Web research helps, but only if retrieval quality and synthesis are strong. And a confidence number can look precise without being well calibrated. So the practical win is not perfect truthfulness. It is a more inspectable workflow that can escalate weak answers instead of hiding the weakness. The noisy part is the temptation to read this as solved reliability. It is not. The source describes a thoughtful coding implementation, not a benchmarked proof that confidence estimation is accurate across domains. There is no evidence here that the confidence score is calibrated against ground truth. only that the system can produce and revise one. The web search fallback is also useful but not magic. Search can inject fresh evidence, yet it can also add irrelevant or low-quality material if retrieval is weak. And the article focuses on a clean notebook workflow, which is different from production concerns like rate limits, prompt drift, source quality controls, and domain-specific evaluation. So, the signal is clear uncertainty should be part of the product loop, not hidden. The noise is assuming self-reported confidence plus search automatically makes an LLM trustworthy. It makes the system more accountable. That is meaningful. It is not the same as solve.